Hello students, welcome back to Vigyan Academy. So today's video will be on the concept of fuse. We will study in this video about the various properties of fuse, what is a fuse, and the current ratings and the various problems that are related to a fuse. So without any delay, let's move into the topic. So let us first discuss what is a fuse. Now, the basic definition is a fuse is a safety device which is used to control the flow of current in a circuit, thus preventing the appliance from getting damaged. Okay. Now, the second point is the fuse must always be connected to the live wire. Now, why should we connect the fuse to the live wire? The main reason is to prevent short circuit. Now, you people are familiar with this word, the short circuit, when the live wire comes in contact with the neutral wire, it creates a zero resistance path due to which a huge amount of current flows through the neutral wire, which causes heat and ultimately catches fire. So, let's discuss about that. Short circuit. When does it happen? When the live wire comes in contact with the neutral wire. So whenever the live wire comes in contact with the neutral wire, you get a short circuit. Why? Because a zero resistance path is created. Because a zero resistance path is created. And what happens during this short circuit? Well, during short circuit, heat is generated or heat is produced. Now, heat has a simple formula of physics, is known as I square RT. We call this as Joule's law of heating. We call this as Joule's law of heating, where I is your current, R is your resistance, and T is your time. So, H equals to I square RT. This gives us the basic fundamental idea of why with increase in current the heat is generated in a huge amount, because we can see that with I you have a square unit. That means if current increases twice, the overall heat increases 4 times. So now that's the basic idea of a fuse. Where should we use it, its definition, and what's a short circuit, and also the heating effect of the fuse. Now let's discuss about the principle of fuse. The principle of fuse is based on heating effect of current. The principle of a fuse wire is basically the heating effect of current. This is actually the Joule's law of heating that we have just discussed. Let me again write it down for you. H equals to I square RT. That is the heating effect of current. Now, when heat increases, it gives rise to, let me write it in proper way. As heat increases, temperature also increases. That's a basic concept of physics. Wherever there is heat, the rise in temperature occurs. So, the temperature rise depends on I square by R cube, or let me write it down this way, R cube. I is your current and small r is the radius of the conductor. Small r is the radius of the conductor. Okay, so from this concept, one thing is completely clear, that I does not depend, the delta T does not depend on the length of the conductor. Okay, so the temperature rise depends on only two factors, that is the current generated in the circuit, or the current passing through the circuit, and the radius of the conductor. Now, when a fuse is made, let's discuss about the materials of a fuse wire. So here you can see that I have given an example of a fuse, something like this. The metal bar or the metal wire in between, this is the fuse wire. This is the fuse wire. Now, the fuse wire is made up of an alloy of lead and tin. A fuse wire is made on an alloy of lead and tin, in which you have 37%, approx 37% lead, and the rest 63% of tin. That's the material used to make a fuse wire. That's the material used to make a fuse wire. Okay, an alloy of lead and tin, where 37% you have lead and almost 63% you have your tin. Now, what are the properties of a fuse wire? What are the properties of a fuse wire? Number one, low melting point. a fuse wire must have a low melting point around 250 degrees Celsius. Number 2, high resistance. So there are two primary properties of making any material a fuse wire. That is, one is low melting point, the temperature should be around 250 degrees Celsius, and the second one is high resistance. Now, a question often comes that why don't we use copper or other materials as a fuse wire? Now, before we move into those concepts, let me just show you the second diagram so that you can get a much more clear concept. Here you can see that these black portions are the two cases of a fuse wire. Here in this picture you can clearly see there is a porcelain holder inside which this blue live wire is placed. I am again repeating, a fuse should always be connected to the live wire. There is no use in connecting it to the neutral wire or the earth wire. It must always be connected to the live wire. So as you can see here, the fuse is kept within a porcelain box. Now the question may arise that why do we prefer a porcelain holder? The reason is it acts as an insulator. It acts as an insulator. Okay. So there's no other reason to keep it inside porcelain. Just because it acts as an insulator, we keep it in. So just see the picture board once to get a clear concept about it. Okay. Now let's move forward. Now the question that I was talking about, that why don't we use copper or aluminium as a fuse wire? There is only one reason, that is copper or aluminium have high melting point around 1000 degrees Celsius. They have high melting point around 1000 degree Celsius. Okay. Now let me just say you one thing. There is one more important topic about the properties. Let me go back to the previous slide. Just add one more topic for the properties. The wire should have a uniform cross section area. The wire should have a uniform cross section area. Please copy it down. So our next topic is current rating of a fuse. First, let's learn the definition of current rating. It is the maximum amount of current that a fuse can allow to flow through it without melting. So, the current rating of fuse is the maximum amount of current that a fuse can allow to flow through it without melting. Remember, every fuse has its different amount of current ratings. It depends on the appliance which it is used for. Let's take an example. We have fuse of 1 ampere, 2 ampere, 5 ampere, 8 ampere, 10 ampere and 15 ampere and so on. So that means a 1 ampere of a fuse can allow a maximum current of 1 ampere to flow through it. After that, it will melt. A 2 ampere will allow a maximum current of 2 ampere current to flow through it. A 5 ampere fuse will allow a maximum amount of 5 ampere current to flow through it. So, to judge which kind of fuse or which current rating of fuse you must use for an appliance, we need to use a formula known as the current rating of fuse, which is equals to power of the appliance by voltage supplied. That is the formula used to calculate the current rating of a fuse. The current rating of fuse is power of the appliance divided by the voltage of the source. Now remember one thing, more the current rating of fuse, more thicker will be the fuse wire. More thicker will be the fuse wire. That is, thickness increases. So, more the current rating of the fuse, more will be the thickness of the fuse wire. Just go through this statement once. Okay, so now let's go to the next part. Let's have some practice problems to clear your concept much well. So the first question is, an electric motor of power 1.5 kilowatt. An electric motor of power 1.5 kilowatt is to be operated by a power line of 220 volt. That is your supply voltage. Find the current rating of the fuse to be connected with the motor. According to our formula, current rating will be equals to power by voltage. So that's equals to, always convert the kilowatt into watt. That's 1500 watt by 220 volt. This comes to around 6.8 ampere. This comes to around 6.8 ampere. So any fuse which has a current rating of more than 6.8 ampere will work for this appliance. But in general uses, we prefer to use a current rating, fuse of current rating quite a bit more than what it is calculated. Let's say for this example, for this appliance, we will use a fuse of current rating around 10 ampere. Current rating of 10 ampere. Now it might come to your mind that why do we need to use 10 ampere fuse for a 6.8 ampere appliance? We could have easily used a 7 ampere fuse. We could have easily used a 6.8 ampere fuse. Why 10 ampere fuse? The reason is, whenever an appliance starts its function, the initial stages, at those initial point of running, it consumes a huge amount of wire. That is the general requirement for every appliance. Now let's say you provide this appliance with a 7 ampere fuse. That's fine, 7 ampere fuse, because according to a calculation you have calculated 6.8. So 7 ampere fuse would have been quite okay. But when the appliance starts, it will require, let's say, 7.5 or 8 ampere current. What will you do at that time? At that time, if the appliance is using an 8 ampere current, the 7 ampere fuse will get blown off. So it won't work. So to make the appliance get the heavy voltage or heavy current during the initial starting, we generally prefer to use the current rating of the fuse a bit much higher than the calculated value. So let me just write it down. During the start of an appliance, the current consumption is high. So, we prefer a fuse with current rating higher than the calculated value. Just go through the context to get your concept clear. Next, this is a question. A house has a main fuse of 5 ampere rating. 8 bulbs, each of 50 watt, and 2 tube lights, each of 220 watt, are used simultaneously. Find the current drawn from the mains of 220 volt. The number of additional bulbs, each of 100 watt, which can also be lighted for a festival day. So this is a question. Let's try to solve it. First, you have a fuse rating of 5 ampere. Let's write it down. Fuse rating, equals to 5 ampere. Now you have 8 bulbs, each of 50 watt. So that's total wattage of bulb is equals to 8 into 50 equals to 400 watt. You have 2 tube lights, each of 20 watt. Total wattage of tube light watt. Now, so total value is coming to as 440 watt. Now, the current drawn from the main is 220 volt. So let's calculate the fuse rating. So our current rating is equals to power, which is 440 by 220. That's 2 ampere. So we are getting that we need a 2 ampere fuse to run all the appliances. But we already have a 5 ampere fuse. So that's extra 3 ampere. Now they have asked the number of additional bulbs, each of 100 watt, which can also be lighted on a festival day. So 100 watt, how many extra 100 watt bulbs can you put so that this full 5 ampere value is consumed? So let's assume we connect X numbers of bulbs, additional bulbs. Each having a wattage of 100 watt. Therefore, total wattage is equals to 100x. Clear? If we add this value to 440, we can say new total wattage is equals to 440 plus 100x. Clear? Now we have a fuse rating of 5 ampere. running at 220 volt line. So let's use, therefore, 5 equals to 440 plus 100x by 220. That will be so you can connect extra 6 bulbs of 100 watt so that the full 5 ampere fuse is used. Go through the sum once. Okay, now let us come to the last context of this chapter. Sorry, not the last context of this video, that is about MCB. The full form of MCB is miniature circuit breaker. This is the advanced form of fuse, okay? The advanced or the modern form of fuse. It has two advantages. Number one, no new fuse wire needs to be connected every single time. And number two, it's safe and very fast reaction time. That is around 25 millisecond. So the miniature circuit breaker is an advanced form of fuse that is used in our modern days that you have seen in your households. The two new advantages are that every time your fuse blows up, you do not need to connect a new fuse wire, you just need to put on the fuse. Next, it is safe and it's very fast reactive than the older fuse versions. Just go through the topic once to get your context clear. So that's it in this video. We will be discussing about the plugs and socket in our last part of the video. Till then, like, share and subscribe. Thank you.